Good evening, everyone. So, welcome to the discussion on biomass conversion and biorefinery NPTEL course. Today, we'll discuss the assignment problem on sixth week and a little bit discussion on the semantic content, which will be helpful to you to solve the assignments. So, unfortunately, till now, no one is joined, but hope so someone will be joined during the session. Okay, so I am sharing my screen. Uh, Now I am opening the today's discussion presentation. So today we will cover the two week discussion, the week 6 discussion on which we are just go through the solution of the assignment for the week 6 and which is the microbial conversion process. Let me okay. So now we are in the slideshow mode. So the week 6 discussion is on microbial conversion process, and the week 7 the discussion was on biodiesel, and we'll go through the important aspects of this week 7 discussion which will be helpful for you to solve the assignment problem. So our faculty in charge for this course is Professor Kaustuba Mohanty from IIT Guwahati. Now, I again wanted to introduce myself if someone is watching this recording or live session for the first time. So, I am Bhavik Kumar Mahant, PhD student in the Chemical Engineering Department at IIT Madras. Why I am attaching my introduction every time? Because if you want have any doubt and if you want any discussion on the discussed topic or any in general discussion related to this course, so you can contact me on this mail ID on the mobile number which is given below, which is my WhatsApp number also. Okay. So first we started with the sixth week discussion of the microbial conversion process. So in that, what are the assignment problems are there? We already discussed in the last class the important aspects related to the assignments, and now today we are discussing the actual assignment questions and the answer of that particular question where it came from, and after that we will switch over our discussion into the week 7. So the first introduction of week 6 started with this slides, a microbial conversion process. So it consists the biochemical conversion process allows the decomposition of biomass to available carbohydrates. So microbial conversion process, the major part of discussion is we are available carbohydrates are present are there. So we are decomposes our main biomass in raw material into the carbohydrates, and after that we can convert it that into the liquid fuels and the biogas by using bacteria, enzyme, such kind of biological agents. This is all about the microbial conversion process. So in this process, soluble and gaseous metabolites including alcohols, volatile fatty acid, methane, carbon dioxide, hydrogen can be produced. There will be not only one kind of product, you will get various different kind of products and gas molecules by using this process. And there are some of the example of this processes was mentioned, like anaerobic digestion without in the presence of oxygen or air. We are going for the digestion in the presence of microorganism. Fermentation process, microbial fuel cell or microbial electrochemical systems, and composting. Composting is the process where we use the biomass and convert it into the rich agriculture fertilizers. So the question asked on these details on the 6 week assignment is following which we apart from following which is the process which is not considered as a microbial conversion process. So fermentation, anaerobic digestion and compostings are all our microbial conversion process, but pyrolysis is not the microbial conversion, it's a thermophysical thermochemical and thermophysical conversion process. So pyrolysis was the answer. For this you can go through this content for solving this particular question. Now the first discussion was started on the anaerobic digestion, where we are not providing the air and the digestion process is taking place. So what is it actually? It is a multi-step biological process that is useful not only for waste management but also for generating renewable energy. It has basic four steps. Hydrolysis is the first step, acidogenesis, acetogenesis, and methanogenesis. So series of chemical reactions are taking place during this process, and it is without oxygen. So reaction. So what is the purpose of this? So as you can see, with different kind of biomass which we are using it into the various kind of feedstocks, biomass feedstocks into anaerobic digestion process, and from this we'll get two different kind of product. One is for product in the form of gas. From this we can go for the some byproduct feedstock, and for biogas which is predominantly consists methane gas, we can use it same methane gas for the generation of the electricity for the heat, vehicle fuel, and renewable natural gases. Now whatever the remain part in the form of solid which is there in our this anaerobic digestion process, which is known as a digestate. So it will be useful in the as a organic fertilizer, animal bleeding, other products, and horticulture products. So basically biogas is a mixture of, as we see, methane and carbon dioxide, and it has another traces, as well as digestate is the another part of the digestion process. So the another product of the digestion process. So the feedstock can be, you can use anything, and it can be carried out at mesophilic, which is 20 to 45 degrees centigrade, or in the range of the thermophilic. So there are two different kind of bacteria, you can say, which are useful, mesophilic and thermophilic. So we'll not go into much more detail. Now we go see to our question which was there in the assignment. Biogas is produced by degrade organic matter in four general steps. So there are four steps as mentioned. All four steps mentioned in the all options are the actual four steps, but the sequence is important. So first, we all know that when we are working with the biomass, so first step is we have to convert the first biomass into the primary compound like carbohydrates, lipid, lignin, or different kind of fundamental products. So for that, hydrolysis will be useful. So there are two options, and here is the answer we already see in the discussion. So another is acidogenesis. So and if you just see to after selecting these two, if you just compare it, acetogenesis we didn't mention anything in this chapter regarding acetogenesis. We mentioned acidogenesis, then acetogenesis, and methanogenesis. So the answer is hydrate, acidogenesis, and methanogenesis. Now this is a flow chart of, or you can say the process diagram for the anaerobic digestion. So here you can see that anaerobic digester is there. So we are using many kind of biomass, including the livestock waste, waste from the crops, agriculture feed, waste from the directly we can use the wastewater also, and apart from that, for the urban scenario, we can consider the food waste also. Everything we can go into the anaerobic digestion. And as we discussed, there are two parts. One is about biogas. Biogas has a major application in the field of heat generation and electricity production, and other than that, we are also generating the hydrogen sulfide. So hydrogen sulfide is a very toxic gas, so we have to look after it. And after that, biogas is mainly consists of methane and carbon dioxide, so it is also known as biomethane, which can be directly, if we don't want to go for this sector, we can directly use as a fuel, and we can use it into the gas grade. And the digester has another solid impurity, just is digestate which will be used in the fertilizer, soil amendments, and livestock bedding. So now in the same anaerobic digestion, many factors are important, like retention time, how much time we are providing, organic loading rate, and substrates, which are the microorganisms which we are using. Now substrates contain excessive inhibitors such as ammonia, sulfide, metals, and organic may take the fermentation process more unstable and raw yield of biomethane. So actually what happens during an anaerobic digestion process, so when the process is happening, there are many byproducts can be produced. So there are many, due to presence of microorganisms, it will be not converted into the only one single product, but there are a range of product you will get. But so in this product, some products are the inhibitors also, or toxic compounds also can form. So what the way they are inhibiting basically. So if you are producing some chemical beyond certain limit, then it will be producing again, remain in the environment, and it can hamper to equipment. Suppose it is a corrosive material like S2S is also corrosive, it is toxic also, so that kind of material will be hamper the process equipment also. At the same time, they can also able to hamper the growth of microorganism and their metabolic activities. So in such fermentation process, anaerobic digestion, when such type of inhibitory compounds are getting formed, it is required that this compound needs to be removed. We have to remove this compound frequently in order to successfully complete our process. Now, there was one question which is on high OLR organic loading rate would boost the acidogenesis stage of easily degradable substrates, and the excessive accumulation of DAS may further inhibit the activity of microorganisms. So, we'll see in the discussion where it is mentioned. So, if we go with the short hydraulic retention time, so hydraulic retention time is the one important factor, another is the OLR. So if you have very short hydraulic retention time, then it would lead to wash out our microbial communities. And so retention time basically require what is it's how much time say the feed is going to be spent or going to be processed inside a particular reactor. Now the questions which was there in the third assignment problem, which is solved here by mentioning that high OLR means organic loading rate. That means organic loading rate will boost the acidogenesis states. So here it is mentioned that acidogenesis states of easily substrates and the excessive accumulation, what it can be possibly do. So excessive volatile fatty acid, excessive accumulation of volatile fatty acid may further inhibit the activity of microorganisms. So I think I omit that line which is there inside this. So but yes, you can consider another discussion is there before this hydrolysis part. In that it is mentioned that after this boost the acidogenesis state, excessive accumulation of DAS will be further inhibit the activity of. So volatile fatty acid will be there, which will be excessively present, and they will be hamper the activity of the microorganisms. So if we just say that a anaerobic digestion has 4 steps, first we start with the hydrolysis. Then in the hydrolysis, complex biopolymer will be broken down into the monomers and oligomers. And then in the another step is acidogenesis, where we use a bacteria which will be convert our biomass, monomers and oligomers into the acids. So in that some kind of sugar amino acid directly converted into the hydrogen and CO2 mixture, some can be converted into acetate, and in between some can be converted into the short chain volatile organic acid by acidogenesis process. After that, the other step is the acetogenesis. So after this acetogenesis, it will be converted into the acetate, and that is known as the acetogenesis, and the product, this bacteria which is generally used for that is the acetogens. And from acetate, then you will use the fourth phase, which is the methanogenesis, which can convert the final acetate and hydrogen CO2 mixture into the methane CO2 mixture. So it will be noted that most of the first step is the hydrolysis. I represent the initial phase of process. Very large organic molecules such as fats, carbohydrates, protein converted into the smaller molecules as a fatty acid, simple sugar and amino acid. That is the main purpose of the hydrolysis. It should be noted that most of the large molecules are further decomposed acidogenesis stage. On the other hand, byproduct resulting from the hydrolysis stage, including hydrogen acetate, are used in the final stage. So in the same, there was another question, fourth question, which is in which phase of the anaerobic digestion biomass consists of very large organic polymers such as fats, carbohydrate, and protein is converted into the smaller molecules such as fatty acids, simple sugar, and amino acids. So answer is the hydrolysis, as we mentioned here just now. In the first step itself, it will convert into the simple sugar, amino acids, and smaller molecules. Now the second step is acidogenesis, where we convert we are using the acidogenic microorganism, which are basically the fermentative bacteria, further decompose the product of the hydrolysis stage into the producing some various products or byproducts like ammonia, carbon dioxide, hydrogen sulfide, alcohols, light volatile fatty acid, carbonic acid, and certain alcohols. So as you can see here, After hydrolysis, whatever you have the monomers which will convert with the hydrogens convert to hydrogen CO2 and short-chain fatty acid as an alcohol. So it's only partially decomposes the biomass. The final products of methane will be taken place by the in the acetogenesis process. So in the acetogenesis, as you can see that this H2CO2 and short-term fatty acid will be converted into the acetic acid, so which is known as the acetogenesis step. So acetogenic, here we are using microorganism which is known as the acetogenic microorganism. So you will get the acetic acid, carbon dioxide, hydrogen at the end, and now acetogen finalizes the breakdown process of the biomass in the facilitating the action of the methanogenic archaea to produce a methanous bioproduct. Now we also visited another topic after anaerobic digestion. There is a second is the fermentation and then composting and all. So fermentation is the second step, second type of biomass conversion process which we are using the microorganisms. So fermentation is the enzyme catalyzed metabolic process where bioorganism converts starch sugar into alcohol and or an acid or an hydrogen anaerobically releasing energy. Now fermentation process, as you can see, is an anaerobic biochemical process where air is not used. We are not use air, or it will be in the absence of air. The first process is the same as the cellular respiration, which is the formation of pyruvic acid by glycolysis, where two ATP molecules are used. So as you can see that first we are glucose get converted into the pyruvic acid by using the glycolysis step. So glycolysis step, and it will be converted pyruvic acid, and same as the respiratory cycle, and two net ATP molecules are synthesized. So what is the question? How many ATP molecules produced during the glycogenesis of glucose to pyruvic acid? The answer is 2, as we just see. Now if you just want to go to the process, and pyruvic acid will be converted into the lactic acid or the alcohol fermentation. There are two different kind of route. If you are using the anaerobic bacteria, then you can follow this route. By using the yeast, then you can follow this route. And from the lactic acid also there are by depending on the microorganism which are used, you are getting the range of products. Same with alcohol fermentation. So there are basically three kind of fermentation: alcohol fermentation, acidic fermentation, as well as hydrogen fermentation, which were used here to understand the fermentation. There are many other than this, but the professor discussed mainly three fermentations. So first, we also discussed the alcohol fermentation. In that, the end product is alcohol and carbon dioxide. The pyruvic acid is break down into the acetaldehyde, and carbon dioxide is at the end. So here, as you can see, the question asked was okay, first we completed this. The NAD plus is also formed in the NADH. So this is all are the enzymes which are using in the fermentation. Fermentation, not only we are using microorganisms, but at the same time we are also using the enzymes which can catalyze our process. So these are two kind of enzymes which are responsible for doing this kind of reactions. So microorganisms commonly used to carry out the process are Saccharomyces cerevisiae. While the fresh stocks use this types of process categorization to different kinds of sugars, starch, and electrolytic structure. So the main purpose is we have a question of the theoretical yield of the alcohol when in the alcohol fermentation from the 100 gram of glucose. So it is mentioned that theoretical yield is 31.14 gram of ethanol and 48.86 gram of carbon dioxide. So if you just talk about the alcohol, then 51.14 gram of the ethanol which is got produced, that is alcohol yield. And another question on the same alcohol fermentation was there, which is a common produce along with a product during all kind of fermentation process. So end product is alcohol and carbon dioxide. So carbon dioxide is the all common product everywhere we are getting. So that is the answer. Now another is the acid fermentation. As I mentioned, one is the acid fermentation, alcohol fermentation, hydrogen fermentation. There's three are the mentioned into the particular biomass conversion and biorefinery course. So another, if we talk about the acid fermentation, it has a subdivision of the lactic acid fermentation. There's another different kind of acid depending on to the process as well as reaction and the microorganisms which were used to going for the fermentation. So acid fermentation is subdivision of the lactic acid fermentation. So lactic acid is formed from the pyruvate produced in the glycolysis. We already see that pyruvic acid and pyruvate it can be converted into lactic acid in the presence of some kind of microorganisms. So enzyme and which enzyme we are using? If we are going for the lactic acid production, then we are using the lactate enzyme, which has which can dehydrogenase catalyze this reaction. Lactic dehydrogenase, the whole enzyme is there. It's the enzyme that catalyzes this reaction. And where we are, what is the bacteria or microorganism we are using? The bacteria is a lactobacillus bacteria. We are also using the same kind of. We are not using exactly bacteria, but the process of our milk can get converted into curd is the presence of the same lactobacillus bacteria only. Now another two different kind of acid fermentation is the acetic acid fermentation. The common the available daily use product which has a large amount of acetic acid and which will be generated from the acetic acid fermentation is vinegar, and which is one of the most widely used product in the food and beverage, and it will be used in the restaurant industry. It is a two-step process. First step is the ethyl alcohol from sugar, and second, the ethyl alcohol is converted into the acetic acid by Acetobacter bacteria. Another is the butyric acid fermentation, where we are using the obligate anaerobic bacteria and which is specifically Clostridium, which people are using for the butyric acid fermentation. So this occurs in the rating of jute fiber, rancid butter, tobacco processing, and tanning of leather. So this kind of bacteria will be occurs in this kind of processes. And butyric acid is produced in the human colon as a product of the dietary fiber and fermentation. It is an important source of the energy for growth epithelium. Now the question asked in this topic, the Clostridium is highly known for production of what? So answer is a butyric acid. As propanic acid, succinic acid we did mention, and methane is, we are not even concerned of the methane here. Now another is a hydrogen fermentation, where we are formulate the hydrogen from the, it is also known as a biohydrogen production route, and we are using the biomasses. From biomasses there are mainly two different processes. One is a fermentation, another is a biophotolysis. So if we just focus on fermentation, then there is direct fermentation and photofermentation. Direct fermentation, we are not using any kind of solar sunlight and all. So in the presence of mesophile and thermophile organism, you will, by using the hybrid process, you will get the hydrogen as a product. If we talk about photofermentation, when we are using the sunlight or ultraviolet rays as a catalysis, and it will be in the presence of sulfur and non-sulfur, and you will get it then hydrogen. Then apart from this, biophotolysis also process in that indirect biophotolysis, where we are using the cyanobacteria, and we are getting the cyanobacteria algae, and from that we are getting the hydrogen. And direct biophotolysis also using the cyanobacteria and algae for getting the hydrogen out of it. Now here it is mentioned that biomass and waste, if we are using for a pre-treatment, then we will get sugar out of it. From this sugar, by using the different kind of enzymes, we can get NADH, and from that we get hydrogen. If we convert in the pyruvate, and from the pyruvate we convert in acetyl or FD, and from that also we are getting the hydrogen. And from the acetyl CO also we are getting the from there we are getting the ethanol, butanol, acetate, and different kind of alcohols. And from this pyruvate, by using the format process, directly we can get by using the format. So by using the format microorganism, we will get the hydrogen. So this is the hydrogen fermentation. Now we are solving the week 6 assignment problems, and only few are remaining. So there was a question asked from the composting. So what is the composting? Basically it is a method where we collected the food waste source and collection. In the ancient time, India people are using this for composting process, where we are taking the all kind of different kind of waste material, and from that there are mainly currently there are two options. One is a landfill and another is this composting. So we are in the presence of microorganisms or thermophilic and mesophilic bacteria, this whatever the waste is got degraded and converted into the fertilizers, which will be helpful to increase the soil property, increase the plant productivity, and which can able to supply the nutrients to the plants. So these are the some processing treatments So we'll not go into the much more detail, but the question asked was which process is related to humus. So what is actually humus? So humus is the uh, whatever the organic waste which we are taking, which is mainly consists of hydrocarbon, and it is mentioned in the composting also that it involves the three phases. The composting involves the three phases which can use the diverse microflora such as bacteria, fungi, and mesophilic and thermophilic bacteria, or any kind of we are not limited to some particular kind of microorganism. We can go for the any different kind of microorganism, and eventually whatever the organic waste is there, it is converted into the in between intermediate stage which is known as a humus, and from that humus it will be finally converted into the fertilizer. And so here there is two different step. In the second phase the temperature will be increased from 45 degrees to 70 degrees, and here then you have to use thermophiles, which are the bacteria or microorganism which can use it with high temperature, and the mesophiles which can be used at a lower temperature. So the question was covered from that. In bioreactor there was a question on baffles. So which is following is not use of baffles. So baffles are basically whenever we are using any kind of reactor, not only for bioreactor but generally in the normal reactor also we have this baffle system in it. So baffles is the plate kind of material which we are using, metal plate, and which can prevent a vortex which are forming to expand the aeration capacity, and which can consist of metal strips. Okay, so this is attached to the wall. So what happen when you provide stirring into the reactor, so there will be chance to generate this kind of vortexes, and then it will be chances that your material will be overflow. So that's why people are design engineers put the buffers in it, so which can be also minimize the microbial growth on the side of the fermenter. It can prevent the vortex to improve aeration, increase the effect of agitation will be fine, and at the same time as we see the aeration efficiency will be fine. Effect of agitation prevent vortexes. Whatever the vortex is generated in the reactor which will be taken care of by these baffles. So what is the incorrect in out of this? So improve the fermenter capacity. So capacity will be not enhanced, capacity will be as much which we designed. So whatever the fermenter or bioreactor which we designed, that will be same only, just we can enhance the uh, productivity in the terms of lower down the vortex formation, lower down the enhance the aeration effect or mixing probability and aeration. So now we will start our discussion on the biodiesel, week 7 discussion of biodiesel. So actually there are so many information is there in this chapter. So mainly I cover the important fundamental information which will be useful for the solution of your assignment problem, as well as some specific slides I included which will be helpful for your assignment problem. So it will be I can't able to cover each and everything, so mainly in between I add some important slides from which already assignment questions are there. So our main focus is the biodiesel. Okay, so biodiesel, if you think, then basically biodiesel foreign if you see in the US, Brazil, as well as in European market, people are using the oil crops, and from there they are using the many kind of vegetable oils directly, like and most of them are using soybean oil, sunflower oil, and rapeseed oil. So but in India we are not using all this oil because directly, because these oils are we are consuming as a food here, but in the foreign countries, due to the requirement of oil in the food is not that much, and it will be easily covered. So whatever excess amount of agriculture they are developing, they are using the oils or oil seeds, they are extracting the oils from the seeds of the particular flower, and they refine in the crude oil, and they can convert into the alcohol. So from the alcohol there is one process which is the transesterification process. We'll see into much more detail in the upcoming slides. So the alcohol, for using the transesterification process, you will get the two product. One is a biodiesel, another is a crude grease oil. you will get a glycerol. So glycerol is there and the biodiesel is there. So whatever the biodiesel which you are achieving out of it, you can use it is claimed that you can use into the transportation directly, but generally people are blending this biodiesel into their our existing gasoline or diesel fuel, and it will be used as a blend rather than the pure biodiesel. So basically trend which we just see the content, because sometimes it's used for the assignment problem. So non-renewable fossil-based fuel was triggered research and development of alternative energy. Now because of it is in the depletion condition, people are searching for the alternative energy resources. Then the biodiesel is one of the most promising revenue. So what are the if you compare is the normal petroleum diesel, then what are the advantages of the biodiesel? It has a low exhaust emission. It is biodegradable, obviously, which because we are using the organic material to generate it. It is a non-toxic as well as renewable. It is a free of sulfur, so there will be very less chance of getting the sulfur here, while we are taking the petroleum diesel which we are getting from the petroleum crude oil. So petroleum crude oil has a sufficient amount of sulfur which is taken from the earth crust itself, so it will be difficult for us to remove the sulfur in a larger extent. So it's a renewable, environment friendly, so it can shift towards our energy requirement can be shifted toward the sustainable energy. And there are many different kind of oil can get from the soybean, camelin oil, safflower oil, sunflower oil, rapeseed oil, castor oil, jet oil, many more. So if we just think about the vegetables which we are using in the use as a consumption of vegetable oils, then the maximum amount of you can see that consumption is come from the rapeseed oil. Rapeseed oil is in the if you just want to understand, and it can be the mustard oil which we are using in the daily. Mustard also we are using in the daily kitchen the daily cooking purposes. And in the Hindi it is known as a sarso ka tel, if someone can't able to recognize it. Then other than that, the major part is comes from the soybean oil. Soybean is people are using multiple at the high in the higher demand, and then preceding with castor oil as well as so now castor oil people are not using in the cooking, obviously, but there are many different applications of this, that where we are using the castor oils and the sunflower oils. At the same time, the another coconut oil, sesame oil, and different kind of oils that is using in India. So these all are oils are generally not useful in terms of Indian scenario to go for the biodiesel production. So what we are Indians are Indian scientists and Indian researchers and Indian organizations which are working on biodiesel are using. So they are using the different kind of oil which are non-edibles. Okay, so these are the oils. Sorry, not oil. These are the plants which generate a non-edible oil. So so it will be not recommended to eat this kind of plant seed or directly getting oil out of it. So most famous example is the mahua, karanja. So how it is look like? I attached the photos. Polanga, as well as neem and rubber and jatropha. So now in the past lecture we also see that the jatropha oil so do you also get the jatropha oil life cycle in the past one of our as a big discussion, where we already discussed that whatever the jatropha seeds are there, which we discuss here, jatropha is non-edible oil, so India can be use this kind of seeds or oils to generate the biodiesel. So which is this jatropha seeds is, it's when you talk about the whole life cycle, then the seeding to the maturation and the fruit, it will take so much amount of time. So that's why jatropha is not that much attractive in Indian scenario. So and that's why what are the lacking in this disadvantage of Jetropyl SIP, which we already discussed in the past some of the lectures. So other than that, if you just want to see how the seeds look like, so the mahua, it's a plant is looks like this, but the seeds are like this, and also this is all are non-edible, so we can convert it into the uh, oil, and then we can produce a biodiesel. Not only India but many South Asian countries are using this. So Karenja is there, and Polanga, so how it is looks like, and neem we all maybe see the neem seeds, rubbers are there, and Jetropyl. Now if we we have to understand the important slides which is presented by professor, that what is the main component of this kind of all kind of oils, so what is available in that, and how we will go for the next step to convert it into the biodiesel. So the major component is a triacyl glycerol, so which called as a TAG or tag or triglyceride, and which is also called as TG, so which is there in all kind of these vegetable oils, and which has three esters. So first you understand what is ester. Ester is COO and R. So here is a carbon chain, here also some carbon chain, and so this is a ester group, so which is a glycerol backbone, so basically the glycerol group. So you have, and glycerol is the three carbon chain, this one OH. So I think, yeah, if you want to see that what is a triglyceride, so this is a triglyceride. You have R1, R2, R3, three different kind of carbon chain is there, but three different kind in the sense that their numbers are not same in all these three. Suppose 16, 17, 18 or 16, sometimes same also, but majorly generally people the compound has a different kind of carbon chains. So and it is called COOR. So here you know that we consider that one end is the different carbon chain, the another end is attached with the glycerol material. So glycerol is a three carbon chain, CH2, CH, CH2. Now if you suppose that it doesn't have the one of the carbon chain with it, so it is a diglyceride, because it has only two aldehyde is available. So diglyceride, only why yes, so diglyceride, so CH2H, and another two carbon chains are there. If it two carbon chains on another carbon chain is removed from this, then it will be converted into monoglycerides. So these are known as MEG or monoglyceride MG or monoglycerol. If you can give the two different name, same compound can be known as a two different name, monoacyl glycerol. So where you can see two, because of three carbon it is a glycerol, and then is the monoacyl, so mono carbon chain is there, or monoglyceride, same as di and tri. Now what is the difference here? There is another thing, that in a vegetable oil you will get the saturated fatty acid as well as the unsaturated fatty acid. So nowadays also when you watch the advertisement of the many cooking oil, either it is a rice bran oil or soybean oil or sunflower oil, they also mentioned that omega 1, omega 3, good fatty acid is there, no bad fatty acid is not there. So for that, basically every kind of this kind of vegetables oils mainly consist three kind of fatty acid. One is a saturated fatty acid. Saturated fatty acid means, saturation means when carbon get all of its valency got filled with some material, some of the compound like hydrogen or let's say oxygen, then oxygen is like that, hydrogen, then it is saturated. If carbon is attached with any kind of double bond, then it is not saturated. So here you can see, if it is double bond with oxygen, then it was not considered as a unsaturated. When carbon has a double bond with carbon, then we are going for the because this is a reactive group. So saturated fatty acid, you will not find any double bond in between in the chain. Unsaturated trans, so trans and cis are the two different kind of configuration available in mainly organic materials. So as you can see, it's in the trans, if whatever the double bond is there, opposite to that hydrogen molecule is on the opposite direction. So always trans means opposite, so here and here, and if both are in the same direction, then it is known as a cis. So it's a Greek word. So cis is in the same direction. So this is a two kind of unsaturated. Saturated is one, unsaturated is two, different kind. Other than that, everything is fine. So unsaturated is you have to find a double bond, and then you have to see the configuration of hydrogen into it. If it is in the opposite direction, then it is known as a trans unsaturated fatty acid, or if it is in the same direction, then it is known as a cis saturated fatty acid. Now there is one concept in this, that how we can understand that which vegetable oil is better, and how we can find this amount of saturation and unsaturation of available in our vegetable oil. And the same method can be used for find the calculate the molecular weight of the vegetable oil. So how it will be taken care of? So there are two different kind of things. First we read the things. The degree of saturation, unsaturation and molecular weight of vegetable oils can be calculated by two things. One is the saponification value, another is the iodine value. So now you have to understand when this iodine value, saponification value will be higher, and it indicates that your vegetable oil has a higher degree of unsaturation, so it has more double bond, and it reaches lower molecular weight. So what is iodine value? So this is a definition. So it is a number of grams of iodine that reacts with 100 grams of fats or oils. So whatever the grams of fats or oils of this particular vegetable oil you are getting, so you have to react it with the iodine, and whatever amount of iodine will react it is known as the iodine value. So you have to understand, so whatever the fats or oils is present, you have to just react with the iodine, and you have to see that what is the amount of iodine you got reacted. Another is a saponification value, a saponification number. It represents the number of milligrams of potassium hydroxide or sodium hydroxide required to saponify 1 gram of fat under the conditions specified. So this is a standard test. So you have to understand fatty acid has acid at the end, okay? So COOH. So now if you react with the any strong base like NaOH and KOH, then what happens? This hydrogen at the end of acid will be replaced by the COONA or COOK, and H2O will be removed. Plus H2O, you will get the H2O. So from this reaction is known as a saponification reaction, and from this they will calculate that how much amount of sodium hydroxide and KOH is required, and that has the can be measured the average molecular weight out of it. So if you want to see some of the example, then iodine value, an example of some of the crude oil, better professor listed out the many different oils iodine value and many different characteristics and properties. So I will again not put the same thing again and again. So but in your understanding, you can see that corn oil has iodine value higher, followed by the peanut oil, sunflower oil, rubber seed oil. So these all has a high iodine value. Means high iodine value means they have the very high unsaturation is there, and due to that their molecular weight is very lower. So this is just for your information. If you want to find the saponification value from any of the oil by using the process, then there is a standard process you have to follow, and at the end you will get the molecular weight. You have to substitute the value of your process which you follow. In that you have to find the molecular weight of acyl glycerol. So suppose if you this is a function n into molecular weight of KOH into 1000 upon molecular weight of acyl glycerol, so which is using for the saponification. So molecular weight of acyl glycerol means your fat or fatty acid or whatever the oil sample you took, and if you take the n equal to 3, so n is the number of I think okay, so I don't want to misguide, so maybe I will again check, because again we will discuss this thing into the next class by assignment solving. Then I will again explain you this thing. So this will be not helpful for you to understand in your exam and assignment. This is for your information only. So on the other thing, iodine value, if you want to consider, then you have to how much molecular weight of iodine, how much iodine you are using into 100. And this is, I think this is for same like for the KOH, how much KOH is your NaOH or KOH you are using, depending on the what material you are using. From that you are getting the number of iodine value out of it. Okay. So vegetable oils composition, so they are already mentioned by professor very in the very detail, and so many different informations are there. So I am not want to pitch each and everything again and again, but if you just see that there will be saturated fatty acid and unsaturated fatty acid in every kind of oil. So in that also you can remember that mainly 16, 17 and 18 are the fatty acid which will be predominantly available in major fatty acid which we are getting from the oils, vegetable oils. And out of it also in 18 also, if you have the 18.1, 18.2, 18.3, there is small difference in the 18 carbon chain, then you will again get oleic, linoleic and linolenic acids. And these are the main compound in all kind of oils, whether some oils in the higher amount and some oils a lower amount. But you can see one thing, that saturated fatty acid is anyway is lower than the unsaturated fatty acid, except the case of palm oil. If you are using the palm oil, then it has a very high amount of saturated fatty acid, and which will be useful to produce the higher amount of biodiesel out of it. So this is just for the information. Now, so as we say, what is a transesterification? So transesterification is the reaction where triglyceride will reacted with the methanol. So glyceride will react with some of the alcohol, so in the presence of catalyst and base medium. So you will get the fatty acid methyl esters, which is actually biodiesel. So what is it actually? So as you can see, it will be breakdown, and this backbone of this molecule, which is a uh, main part of the structure, and then all the part will be removed out of it. So CH3 3 moles of methanol we are using, so one mole is connected to each one of it, CH3O CO in the form of OCH3 at the end. And you will see that it is COOR COCH3 or RCOCH3 OCH3, sorry, RCOOCH3. So this is actually the whatever our diesel is there, which is methyl esters. So this is esters, R both side R is there, COR. But here after O you have the methyl group, CH3 group everywhere. So it is a methyl esters. And you will get the glycerin because the backbone you are react with the hydrogen, all the hydrogen is connected here, then you will get the glycerin. Now the process if you talk about, then there are many ways. If you talk vegetable oils directly, then you can go for the transesterification, and you have to add the methanol and NaOH. NaOH is the basic medium which we are using. So after transesterification you will get the crude glycerin and crude biodiesel. Now waste into vegetable oil, there is another approach people are using. They are blend the vegetable oil with the waste oils. So waste oil is waste, not only is a waste oil, but many kind of waste, but basically waste which has like cooking waste or urban waste which has oil things. Or if you talk about waste cooking oil, or oil generated from the restaurant and all waste oil generated from that, and some other waste you can use it. And here for that we have to first go for the acid dilution, and after acid dilution you can convert is most of the unsaturated fatty acid into the saturated fatty acid. And sorry, you can again use the same transesterification reaction, you will get the glycerin and biodiesel. And after that, this first you will get the in the form of the crude. Now the crude, in the sense it has some impurities in it, so you have to refine it into the proper purity. So from the refining, you have to use some operations like adsorptions or some wet or dry methods, and at the end you will get your final purified glycerin and purified biodiesel. And from the refining, whatever the methanol you are getting, which you can recover both, and from this methane, recover methane, you can again use it into the transfer esterification process. Now I add only 2-3 oils in between. I don't want to go through the much more details because they all maybe go through the lectures of professor, but I just add 2 oils, soybean oil and rapeseed oil, because there are some questions based on this oil which is there in assignments. So soybean oil or soya is referred as a glycine mix. So what is a glycine mix? It is the basic scientific name which is found under cultivation. Is a member on this soybean is a member of the Papilionaceae family. So this is a particular scientific name of the this group of vegetables comes from some particular group of family that we don't have to bother about. So origin of, now what is the origin of soybean is not very clear till now, people doesn't know, but the genus glycine has a 2 major gene centers. Now they are, how they are understanding that this plant and this species comes from the which part of the world. So they are taking this DNA and they go for the genome sequence, and from this genome they are finding that the similarity between that particular gene into and other available worldwide genes. So it is either from Eastern Africa or Australia. It is their origin of this soybean. So many teachers will tell us that this soybean has been originated from Eastern Asia also, but there is no proper proof. So it's fine. This is all information also. And northeastern China has been considered the region of origin of soybean domestication. So domestication is a type of soybean which we are using it each and every part of the world. So which is a current type of soybean. So it is the world's largest oilseed in terms of the total production and international trade. Obviously, because it is a higher rich in protein, people are using in a good source, as a good protein source. So it soybean seed of oil content ranges from 15 to 20%. So okay, someone is wanted to join. Okay, so we are discussing the week 7 content, which is a biodiesel. We already covered the 6th week content of all the assignment question, and not covered the question whole content, but we covered the all the assignment questions and from the answer where from it come from. Okay, if you don't want to join, then why should I don't have to repeat each and everything again. Anyway. So there is one major fatty acid is available, which is a oleic acid, and when it is represented at C18 has 1, then it can be mentioned that it has 18 carbon atoms and which has one double bond, and C18 carbon chain, and which has a one double bond, which is known as a linoleic acid. Okay, so another is a rapeseed oil, mustard oil, or canola oil. Any kind of different name you are giving, is the same group of family. So the word rape is, it's a rapeseed. So a rape is originated from the Latin word rapum, which means the turnip. So now this belongs to the Brassica family. So this is a kind of family where the all same kind of vegetables are come from. So rutabagas, broccoli, cabbage, and mustard. Now these seeds have all content over 40%. So in the last we seeded only up to 22%, but it has more than 40 or around or more than 40%. But it has a erucic acid content which is higher than 5%. So it is called here. So high erucic acid. If you have low erucic acid content, then it is known as a LEAR. So LEAR is referred to as a low acid concentration, less than 5. So this erucic acid is should not be exceed more than 5% in terms of the better productivity or production of the biodiesel. Now we are not going for the other different kind of type, but you can see that white mustard seeds are there, blacks are there, browns are there. So mainly black mustard seed has more uric acid content. It is from the research paper. Now even brown also has this uric acid, but the highest is from the brown black. So now the biodiesel production by using the transesterification process. Okay, so if you just see here, then in biodiesel production it is we are generally, we are just in this chapter we are following the vegetable oils, but not only that, vegetable oils, renewable feedstock, cooking oils we can use, as I discussed earlier. So animal waste, if you people are using the meat industry and all the waste are generated, so in the human being also we have the high amount of fatty acid. So what fatty acid is available, so whatever the fat is there in our body, which can be also converted to the biodiesel, and we go for the transesterification process. So first we are going for the transesterification process, or sometimes we have to go for the dilute acid esterification. So the both are the transesterification, we are adding the methanol in the presence of NaOH, and here we have to first using the dilute acid, and then esterification process same. Then you will get the ester, glycerol, alcohol, some catalyst, and monoglyceride. You will get the whatever the catalyst you are using in these processes. At the end, you are getting that one. So from that, you have to separate the things. So you can separate the wastewater, biodiesel, and glycerol out of it, and the catalyst and alcohol you can recover it, and then again you can recycle back it again. If you use the acid thing, then alcohol you will get the acid, and you can recycle this process also. So both of the process you can again recycle. So it's the most common method for using the viscosity for use to reduce the viscosity of vegetable oils and produce biodiesel. So in addition to transesterification of tag, so tag is tag biodiesel. Okay, you can give the name like tag biodiesel also. It can be produced from the free fatty acid through esterification. So transesterification, without other than that, we can go for the free fatty acid esterification like this. And ester is characterized by the RCOO group. Tag is a type of ester and reaction that converts tag into biodiesel, therefore known as a transesterification. When we are using the free fatty acid, it's not an ester, it is an acid actually. So biodiesel from the free fatty acid called we have to convert into the ester, and then we have to make it into ester, and from that we are getting the final product. So it is a reaction between glyceride and salts and alcohol, like methanol and ethanol we already see. So we can convert tag to DAG. First one chain can be converted into the one of onto one kind of methanoic ester, same like this. From like this you can go for the final process, and you will add, at the end you will get a glycerol and biodiesel. Okay, so I think I have doubt that you can able to hear this video, but we will see that I will make you explain what they are explaining. So by watching this video, you can a little bit able to understand. So how this actual process is going on. You can also go through the YouTube and Google. You will find many videos on it, but I chose one of them. So understanding the biodiesel. So mostly videos are uploaded by the some of the industries which they already developed the process, and they are using it as a commercial scale. So they're starting with the greenhouse effect. So even I can also not able to hear currently, but you can understand that what they are explaining. So this is their headquarters, where in the R&D they are using this trans biodiesel. Trans biodiesel means a transesterification process they are using. So this is I will have to stop from here only. As you can see that how this bio all look like. So this is their headquarters where they are doing the R&D and the small scale setup. In the R&D you will find this kind of small scale of R&D, and from this they will transfer it to the pilot scale, and from the pilot scale it will be transferred to the commercial level plant. So this is how there's it will 2010. This is at only the startup. They just start into the Israel for using this trans biodiesel company. The name of company is trans biodiesel, and they started to convert it into the formulate the process. Then in 2014, European Union entrepreneur they converted into European Union, and then in the 2015 in the Peru. So this is their journey, which is not that much important for us. So in China, trans biodiesel. So they are operating their plant into many countries. So now we are interesting to understand their process. So this is how their processes looks like. So so now they are mentioning that where they can use various kind of fatty acid, free fatty acid from various kind of oil. So use cooking oil can be fine, animal fat can be fine, acid oil, brown grease, any kind of oil. Grease will be maybe petroleum product, whatever they're getting as a byproduct, they can use it, all of this. So their feedstock will be so different. So they use the enzymes which can enhance the process. Okay. Alright. I think I can able to. I thought that I can able to move it. So maximum reaction temperature is 25 to 30 degrees centigrade. So it is not high temperature requirement. So now 1 ton of trans enzyme, which the enzyme they are using, that can be used to convert the 3000 to 4000 tons of biodiesel. So you can understand the power of enzymes or catalysts in the experiment and the reaction, that they can only use 1 ton of that enzyme, and it can able to convert the 3000 to 4000 tons of biodiesel. So their expertise in the trans enzyme, yeah, which they develop for this trans esterification process. So this is their process, how it look like. So it's a small scale setup in the form of animation. So what is a groundbreaking technology? Groundbreaking technology of there in the simple process. So it's animation only. So what is the pre-treatment? So they are providing the pre-treatment and then pre-mixing tech. So if there are two different kind of materials are there, that is also mixed, and at the same time they are adding the enzymes as well as reactants, chemicals in this pre-mixed tank. From there it will go to the first enzymatic reactor. So this is kind of reactor they are using. This you can see it's same multi-scale impellers are there, so bioreactors. And you can see one thing, if you can able to see. So the impeller is there, which is not exactly center into the reactor. It is somewhat off center. So this kind of arrangement is known as a off centric reactor. So why they are using it? So if you don't want to use the baffles and you have to baffles are useful to not overflow your material, and they are providing the strength and not vortex formation. So if you don't want to make this baffle kind of thing, you put this kind of impeller, you have to just shift it towards one side. So this is it can be solve your purpose. So now how his process is going on, they are explaining. So we have the glycerides and free fatty acids are there, and they have the methanol, which we just transesterification whole process we discussed. Now this is an enzyme. So enzyme is like a catalyst. So this all things are go inside. Transesterification processes take place, and you will transesterification at the same time. If you have free acid, then it will convert to esterification. If you have triglyceride, it can convert to transesterification. You will get the biodiesel out of both of it. So this is for the better understanding. That's it. So you biodiesel and glycerol you will get. If you have free fatty acid, then biodiesel and water you will get. Then you have to separate it out. So it will be go into the first. It will go into the crude biodiesel. So this is a crude biodiesel. It's not refined. and it has an unreacted glyceride and free fatty acid. So unreacted material is still there, as well as glycerol and water, excess methane, everything is still available in that. So 96% converted. So their process, they are claiming more than 96% of raw material got converted into the biodiesel, and then they are putting into the different kind of separation process. So ASTM and biodiesel. So this is their final product, which is certified by the ASTM American standards, and they are also getting the glycerol at the other end. So this is also their product, or you can say byproduct. So this is how their process looks like. They didn't mention the separation process, but you can understand that absorption kind of process they are using from that. But due to the privacy, they are not using. So this they are not mentioning. And as you can see, the actual plant, how it is look like. Array. So there, the plant in Peru, it looks like it's very big. It's not a very small scale plant. Okay, let me drink some water. So their technology has ROI, return on investment, 36 months. So if you are purchasing the technology today, so in 3 years you will get your full return on your technology investment, and you will get your profit. So this is about just explanation about this, how actually this transesterification process is taking place. And there is another topic of discussion on the sixth chapter, that is transesterification for algae, which is also renewable source. But if we use sun energy, and algae are using sun energy, if we extract the oil out of it, then from that we can convert the biodiesel. So biodiesel conversion of this oil, you should be, you again use this transesterification process, and you can get protein residue as a byproduct. And from this biodiesel, by using transesterification, you will get the glycerin, and this biodiesel you can use for the transportation. And whatever the CO2 will be generated from this transportation, what is a good part of this biomass or algae based biomass, that whatever the CO2 will be, you will get out of this vehicles or transportation media. So currently people are more using the net zero and carbon capture. So whatever the carbon you are getting, this algae can directly able to capture that carbon dioxide, and this will be used for the development and growth of the algae. So okay, so read some of the professor material, that algae competes the fellow contestant in the biodiesel synthesis market, which give an insight for the future oil demand. So algae oil displays a remarkable tendency. So it is a very important and application in the this biodiesel market. So it has reaction between one mole of triglyceride molecule with complex ester and 3 and 4 moles of alcohol. We already see. So it can be catalyzed. How can be catalyzed? Why I adding this? Because of some assignment questions. So transesterification requires some catalysis. So catalysts either are the acid catalyst or the base catalyst. If you use the acid catalyst, then the sulfonic acid and sulfuric acid are the catalysts which one can use. And base has sodium hydroxide, potassium hydroxide, sodium methoxide kind of bases. And several kinds of catalysts you can use, and the metal oxide, nickel bond, that will be also useful. So the still research is going on to the development of the catalyst. Now biofuel synthesis from the algae by transesterification method. Okay, so first whatever the algae is there, so we have to select the type of algae and site selection of that particular algae. Site selection in the sense, not all algae will be grow can be anywhere into the world. So we have to understand the local requirement, and we have to understand the strain of algae, and from that we have to use the algae, means we have to develop the algae. So it's a cultivation of the algae. So what is required? Light, water, CO2 and nutrients. Then we have to use this kind of algal culture, like if we have water and all these other things are there, we use some amount of algae into it, and then it will be modified and it will be multiply among themselves. Then you will get whatever the effluent, you have to harvest it, and from that whatever the culture is there, you will take out and again use for the cultivation of algae, and whatever the another slurry which can go for the biomass processing, you are going for some process which you already discussed in the previous lectures, and from that you are getting the oil, and if some nutrients are there you can recycle back. So from oil, by using this transesterification process, you will get the biodiesel at the end. So many microalgae, in particular the green algae and diatoms, can accumulate the significant quantities of natural lipids, primarily the triglycerols and THs. So it consists the natural lipid. The lipid has this triglycerols. So this lipid can be extracted from the biomass and converted into the biodiesel, green diesel. Hence you need to purify it. But we have to purify it. So for produce and direct, it can be used in the engine. So after this biodiesel, you have to purify. We already see it for before using the engine. The lipid content is a significant prerequisite determining the aptness of the microalgae for the commercial biofuel production. So lipids are the actually important content, important uh, prerequisite or parameter to understand how much it will be useful to produce the biodiesel. So mainly it contains 30 to 80% lipids, and lipid has this glyceride and also it can be converted into biodiesel. But basically they are not soluble into the polar solvents like water and all. So they are, because lipids are the organic molecule, they are non-polar, so they can be soluble into non-polar solvents. Therefore they can easily extractable using any kind of organic solvent. Now what are polar and non-polar solvents? So we have two different kind of plus minus ions are there. So like water, H plus OH minus, but the organic solvent doesn't like behave like that, so it's non-polar solvents. Now there is another topic is the syngas biorefinery. So syngas biorefinery is, we already see in the last couple of lecture that we can, from this biomass, we can convert it into the synthetic gases, which is nothing but the mixture of hydrogen and carbon monoxide. Now but this production of syngas is not only come from the biomass, it can be easily come from the coal and natural gas. So from coal, if you are reacting with carbon with H2O, so C plus H2O gives you CO plus H2O, and the same with nature gas also. So whatever the syngas you have, we can convert it into the hydrogen methane out of it. But if you are using the Fischer-Tropsch synthesis, by using the Fischer-Tropsch synthesis, you will go for the next step of process, and then you are refining the final process, and you will get the gases LPG, naphtha, kerosene, diesel, lubes, waxes. And if you use the same synthesis, same gas for the in the route of methanol synthesis, so methanol synthesis, which will be converted into dimethyl ether, and from that you will get the various products: propylene, ethylene, gasoline, nitric acid, and oxygenates. So now I don't want to go into the much more detail, because professor already covered in very much detail, and there is so much information is already available. I don't want to bombard you with much more amount of information. So you can watch the lecture, you can go through the notes of the professor. So I touched the name, that it says syngas biorefinery is a huge different value. Why it is biorefinery? Because why petroleum refinery, we are also have the petroleum refineries. So petroleum upstream plants are there and refineries are there. So what refineries are do? So whatever the crude oil there is available, it can be converted into the various number of products, which is known as the petroleum products. Similarly, here syngas is converted into various number of products, and it's a high range of products are there. So that's why it is also known as a refinery. That's it. We discussed before this. So the trans-esterification reaction, it is in the second part lecture of the same week. It's professor is explained this in very much detail. So you can go through it, and you can understand which kind of catalysts, which kind of processes are take place, what is the actual mechanism of this process. Just we will touch some of the part. So this is a backbone, as we consider. This is a glycerol. It will convert into the glycerol, and glycerol is glycerin is the same thing. If you can give the name as a glycerin or glycerol. So now we have to worry about these three carbon chain and COO, which is attached with it. So we are reacting the 3 number of methanol in the presence of NaOH catalyst. So it's a basic medium, and then all of them are connected with the OCH3 out of it, and H is connected with the another part, and you will get the CH3 or CH3 or CH3. OCH3 will connect it here, and you will get this mixture of fatty esters. So it is actually nothing but the biodiesel. So now this is a very simplest reaction in the presence of catalyst. I am again and again I am also mentioning the same reaction because it's important reaction and it is comes again and again in this chapter. So I don't know. It's a result in ester and glycerol. Okay. So anyway, it's fine. We don't have to go too much detail. Then transesterification is an equilibrium reaction describing the alcoholysis of carboxylic ester usually performed in the presence of a conventional catalyst, sodium hydroxide, potassium hydroxide. Chemically, vegetable oils are triglyceride molecule with structure difference. Okay, so this is how it is. This reaction is taking place. So first, one of the this chain is reacted with the one of molecule of methanol and you will get the one methyl ester and diglyceride is there. Then diglyceride is again reacted with the one CH2H and this another is combined together and you will get another methyl ester. And again you are left with the monoglyceride. Then monoglyceride is reacted with the methanol and then it is whatever the one last chain of alcohol is last chain of alkyl is remaining, it will be give you the another methyl ester and whatever the last part is remaining, it is a glycerol or glycerine. Now so I don't want to jump actually, but I thought that I will not get much enough time, so I directly go into the some topic which is important for your assignment problem. I didn't cover the whole detail of transesterification again, and then there are various separation process. Little bit separation process I covered, but there is one part which is a tuning. So professor covered it is, but actually it is a little bit tricky, and I also not cover it into the much more detail. But if you have any problem, then you can come to understand this part again, and we can discuss it in the next or in between also. If you want to understand, you can drop to me, we can discuss it, we'll get a common time. So there is a CO dissociation rate. Okay, so this is all about the very mechanistically carbon in the for the the various properties of the carbon when it touches with some organic material. So it is a whole sort of CO which is attached with some chain of the carbohydrates. So you have to understand CO dissociation rate. So how it will increase and how it will decrease, that is the main concern. So if with that particular CO will get the electron donation group, or it will get the electron out of it, then this dissociation of CO will increase. And at the same time, if someone will take the electrons out of the whole molecules, then the dissociation rate will be decreased. Now it mainly depends on which kind of catalyst you are using. So and from this catalyst you are getting the product. So first we will understand what is the title of this figure. FTS is a balancing act controlled by the localized electron donating capability of the active surfaces. So these are the active surfaces, okay, so which is nothing but the our catalyst. So and it controlled by this whole FTS process controlled by the localized electron donating capability, how much electron it can donate and it can withdraw. Well, X2 and L simply denote the localized carbon hybridization as sp3 and sp2 respectively. Okay, so this is one thing is X2 and one thing is L. So you have why sp3 and sp3 hybridization of the carbon dioxide, carbon. So when it is sp3, when you will get a whole carbon in the form of all bonds are saturated or saturated in the form of saturated, only single bonds are there. If you have double bond, then it will go into the sp2 hybridization. So the other one part is sp3 and another part is sp2 hybridization. Selectivity toward those products increase because of this localized environments. Now depending on this localized environment means depending on to the catalyst and depending on to the availability of the sp3 and sp2 hybrid. Another meaning, availability of unsaturated fatty acid or saturated fatty acid, how much part of yours as molecule is saturated and how much is unsaturated. You can see here unsaturated. It is unsaturated. Then if we are using the cobalt ruthenium, cobalt ruthenium is on mostly balanced. If you are using the K iron carbide or iron carbide, then these are the products you are getting. So this is all about the how to get the product, tune the product depending on the catalyst. This is nothing other than this. So if you use this particular K potassium iron carbide, then the olefins, nature olefins, and ions, one olefins, one alcohols you will get. If you use the iron carbide, then normal paraffins, branch paraffins you will get one olefins, two olefins, acid ketones will be get. Cobalt ruthenium is normal paraffins, one olefins and one alcohol. Same we are using if you have sp3 and if you are using nickel, then you will get the methane and coke. So these are the saturated fatty acids. Generally people want to this methane formation at the end. So this is how this unfortunately I thought that I could not able to cover other parts, so I just added one slide, but we can go to the further discussion after this lecture whenever you will get time for understanding this. But the main thing is when questions come in the assignment, that's why I have to put this slide. Maybe in the next time when we are solving this question of the assignments, we understand how it is be taking place. So this is a part of the adsorption process of carbon monoxide. So that is basically whatever the after biodiesel production process, you will have some separation process in that. The one is the adsorption. In that adsorption, if you want to adsorb the carbon monoxide, then you have to think about this whole things, that what are the other material other than this carbon monoxide available, and you don't have to think much for this because it will be much more confusing then you have to what are the other chemical are available in your reaction mixture or product mixture, and how can you CO can be dissociate in out of it, or how can you adsorb CO out of it. So they have two processes. One is a weak back donation, where carbon monoxide is adsorbed molecularly as the succession or succeeding of carbon bond with a H plus is not kinetically favored. Okay, so it will be adsorbed, but this mode, what is the bond it is created which is not kinetically favored. So it is if carbon monoxide weak, so it can say it's a weak bond. So it is a weakly adsorbed. Then the vinylic intermediate species will be on L configuration, weakly bound to the surface. This one. So this is actually confusing. So I am advising you to not go into the much detail. Just understand the things. Maybe I will share some simple documents on this if you want to know, and that will be helpful for you to understand. So they are again considering this L configuration will be how it can come. So the intermediate is susceptible to hydrogenation reaction and high selectivity to methane and light carbons are observed. As carbon monoxide dissociation is difficult, so after adsorption dissociation is difficult. So how can carbon got from the weakly bound L configured vinylic intermediate? So vinylic intermediates means vinyl is anything where you share C double bond C OH or something, C double bond C and another have O on side. So that kind of intermediate it will form. So the carbon of vinylic intermediate exhibit sp2 hybridization. This is electrophilic in nature, and it is a weak, that because of the weak back donation from the metal. So electrophilic means it will get the electrons. So electrophilic, it attract towards electrons, so it will take the electron, withdraw out of it, and you will get this weak back donation. Another is a semi-strong back donation. It will adsorb in an associative manner followed by the H dissociation on the active side. Adsorb carbon monoxide is stable. So here it is stable as the vinyl intermediate has X2 configuration. The configuration is now X2. So it's a sp3. This is basically the saturation of the carbon chain is there. So that's why your whatever CO is there, which is much more stable. Now we're talking about this configuration. We can call this as semi-strong back donation happening there. This is the metallic surface of the catalyst. These species are suitably stabilized on the active surface to favor chain growth solely at the CX position, and fingerprint of the primary linear paraffins and one olefins as observed cobalt and lithium catalyst. So I think professor also put this all information from one of the research papers, so that's why you can't able to understand the whole picture in a one go. You have to understand the whole process, and then you can able to understand the impact of this catalyst. So I suggest that you don't go into much more detail, because it will be not that much useful for you at this stage. If you go into the more research part of this, then it will be helpful. So they again go for the sp3 hybridization, and from that you are using the different kind of catalyst, and they will get the configuration. That's it. So that's why again after this I put the adsorption slide. Say adsorption is a process where atoms, ions and molecules known as adsorbate form a substance, mostly liquid or gas, added to solid surface called as the adsorbent. So we have some material which is known as adsorbate, and we have adsorbent. So adsorbent is a surface, or solid surface or liquid surface, and this adsorbate will go and react and adsorb in this particular surface. That's it. So adsorbents are basically not only nature, they are man-made or artificial also. So synthetic material can be also possible, but it should be the amorphous and microcrystalline structures. So it should be not whole crystalline structure, whole crystalline. So it will not get the space where this adsorbate can get adsorbed. So amorphous in the sense that it has many porous structure in between, or it has a very high surface area, owning the basic and acidic adsorption sites, where it has either basic or acidic depending on the reactive part, and it has a polar substrate such as a glycerol methanol can be adsorbed. So out of this glycerol methanol can be adsorbed. So where this all things will be worked out after generation of the biodiesel, we have the glycerol methanol and biodiesel. Now you have to separate it out. For the separation process, this adsorption thing can be worked out, and glycerol methanol can be easily adsorbed on this kind of processes. So adsorption loading says, now these are the important criteria. So adsorption loading, so what is the amount of adsorbent you are taking, selectivity of the adsorbent, so one particular kind of product get adsorbed on the particular kind of adsorbent, regenerability after adsorption, if how can you can desorb. So that is why we are discussing about the last slides. Kinetics, how much fast or slow it is a process is, compatibility of this process, and cost is these are the most important criteria. Now the readily available are the silica based adsorbents, and which is known as a magnesol and trisol, which is naturally available, or they are treating the silica into the and thus for make this kind of some reactive silica, where you are getting using this as an adsorbent, bio-based adsorbent, and you are getting this lignocellulosic substrates and activated compounds, including the famous activated carbon. Then you have activated fiber, activated clay are among the most common adsorbents. So these are the different kind of adsorbents you can use it. So I didn't go through much more detail. Then there are mainly three different kind of refining techniques are available. Refining techniques I again mentioned, I already mentioned it after production of biodiesel, but you have to separate out the biodiesel and another remaining amount. So one is a weight washing, so where this washing process is taking place in the presence of some amount of water. So what are the advantages? You can easily methanol can remove, because methanol got solubilized in the water. It can reduce the methanol, soft, free glycerol, whatever the alcohols are there, they are easily, due to the presence of hydrogen bonding, you can solubilize in the water. But what are the disadvantages? Because of presence of water, emulsion formation is taking place. Emulsion in the sense of two different kind of liquid, organic and inorganic liquid, comes into the picture, and then it form the emulsion. They will not directly react with each other, but they make some separate layers in between. So wastewater treatment, no effects on glycerides and different. So glyceride can be not go into anywhere. Consumption of water, Na2SO4, this is also high amount of water you have to use. Loss in product due to the formation of soap and emulsion. Now dry washing, that magnesol can remove free and bonded glycerol, soap and potassium. Magnesol is efficient and has the ability to replace the water washing. It can effectively remove the acetyl methanol. It can save time, lower energy, save capital cost, and lead significant disposal cost reduction. Information regarding the chemical composition of the resin is difficult. Little effects on methanol. What are other disadvantages? Involve the highly consumable in incurring expensive, requires significant resources, larger size of powder grains, making them exceedingly difficult to remove. Now membrane purification is also one process. I didn't cover it here, but it's there. You can go through it. So what are there are many advantages of the membrane process, which can provide a good yield, high purity quality finished products that are comparable to the conventional diesel fuels, staples, and with less energy consumption, provide enormous environmental benefits and energy savings. You can reduce the separation and purification cost, because here you have not provided any kind of mechanical or reaction kind of energy will be provided to the membrane. And quality of the fuel is improved, high recovery of the valuable products, and wasting is also zero. Now disadvantage is organic membrane are less stable and easily get swollen in the organic solvents, so we have to go for the inorganic membrane and no large scale industrial application. Now there is one important this is the last slide. So how we can understand the biodiesel characteristic? So C10 number is the we have to understand. So for this any kind of diesel or another thing, we are using this kerosene fuel or diesel fuel. Kerosene fuel in the sense of air jet fuel. We are determining the property from the C10 number. Now C10 is the actual organic compound, and it is a mixture of organic compound, and then you have to compare it to what is a particular amount of normal C10 is there. So how much percentage of cracking knock tendency you are getting by using this particular amount of pure fuel. And this is a standard mixture of 60%, 40%, 30% of this C10 is there, and you have to take a different amount of mixture, and you have to check the knock tendency. Knock tendency is the when the fuel is using into the engine, then you will say that during the combustion what is the knocking process is taking place, so that you have to understand that from that. So and it's same for the gasoline. You are going for the octane rating, then there we normal octane, high octane, we are mixing it, and then we are checking that different mixture, and we are comparing it to our own fuel. The C10 number is related to ignition delay time, which is the time interval between the start of the injection and the start of the combustion. Okay, so what is how the knock tendency is, what is that? So it is a delay, ignition of the delay time. So injection fuel is already done, the fuel is in the inside, but it does not start combusted. So there is some interval in between. So the more the C10 number, the interval is much more higher. Interval is much more lower, and your ignition is fast. The C10 number increases, the ignition delay decreases, and the main combustion phase rate is a diffusion under combustion process. Similar to low C10 number, high C10 number 2 is inconvenience as well. So low C10 number is also provided a higher amount of delay. But if you go for the low, very high C10 number, then also this maybe fuel may ignite a short distance, and then it can inject so here we are discussing about we are discussing about the C10 number. So why I put this slide, because there is one assignment question, and this is actually last slide of the discussion. So there is two different things, C10 number, octane number, because you maybe heard about in your past studies. So octane number is useful for the gasoline, or you can say the petrol thing, or petrol fuel, or that kind of fuel. If you have diesel fuel or kerosene fuel, then you are talking about the C10 number. The C10 number is the mixture of two chemicals like heptamethyl nonane and normal C10. Like octane, you have isooctane and normal heptane. So this is a mixture of two different chemicals, and then by using the different amount of this mixture, you will say that it required 30 C10 and 70 heptamethyl nonane, or 40 C10, 40% C10 and 60%. So like this, how much amount of C10 is you want in this particular mixture, that mixture will give the same amount of ignition delay as your fuel. Okay, so whatever the fuel is there, if you inject into your engine, then when you start to injection and it will start to combustion, there is some delay in between. So you have to mix this two compound, and you have to check that if your delay is the same like this compound delay, like if you have 40 C10 and this is for a similar kind of delay, you have require 40% C10 and 60% heptamine, then you can see that your diesel or kerosene fuel has 40 number, seated number of 40. So I again explain to you. And then it is known as it is a delay, I already mentioned. And it is, if it is a higher seated number, then the ignition delay decreases and delay is very low. If your number is higher, then delay is low. But at the same time, you have to see that your low seated number is not and as well as high seated number is also inconvenience. If you have very drastical very fast ignition is there, then your fuel will be combusted a lot and your fuel consumption will be a lot. And there will be, you degrade your injector nozzle and all, and that will be harmful to your overall engine. And if you're very low, then your delay will be much more high, then it will be lower the efficiency of overall engine. So your seated number is in the moderate range. That's it. So with this I want to conclude this today's session. And sorry I didn't attach much more things, but if you can understand that it will be like somewhat like boring if I add so much information, because you are already getting so much information in your professor's lecture, so you can get understand the things over there. So here we are just revisiting in the important thing which is part of your assignment that will be covered. So I conclude my today's talk with famous quote from the Dhirubhai Ambani that for those who dare to dream, there is a whole world to win. So, and this is my mail ID. You can note it down if you have more discussion, because very limited time, and this is all exhaustive also at the last part of the, I mean after evening if you are discussing. So it is exhaustive for me also as well as for you. So if you want to discuss, you can mail me, and at the same time I think I gave my WhatsApp number also if you want someone want to understand the details with me, more details of any of the topic or any other doubts in this subject. So with this I want to conclude today, and I want to stop sharing. And with this have a very good evening and have a safe good night. And you can ping me for any of your doubts. So I think if you have any questions, anyone has any questions, I think no one is left in the meeting apart from me. So better, okay, good night, and we'll meet again in the next part of discussion. Bye.